So I just started recording and let's start. So first of all, we're going to talk about what Python is, and there are a whole lot of tools that you can use that work very well with Python. One of them is Conda, another one is Peeppeep, Jupyter Notebook, and we will talk about them, how they fit in, and what problems do they solve. Then we will get to the basics of Python, operators, expressions, control flow, functions, modules, and just a bit of object-oriented programming. And then in the second part of this workshop, I will talk briefly about machine learning, how you can use it, how easy it is to do it in Python, and we will show you a couple of examples. So first of all, is there anyone here that has no prior experience with any programming language? Any programming language? Okay. So this workshop is going to be a bit fast for you because I'm assuming that people have some sort of experience with another programming language. It doesn't matter which one, MATLAB, C++, C, Java, any of them. But the best place to start is Python because it's a very easy to use and easy to learn programming language. So I encourage you to read the slides afterwards. I have a lot of links there that point to great sources that you can learn from, and probably you could do like a Udemy course or something if that is not enough for you. So what is Python? Python is a programming language just like C, Java, C++, anything else. It's free, it's open source, it started as a project to help children learn programming, and then it was so easy to use that it got more popular, and right now it is the most used programming language, and especially among academia it's very well known because you can implement something really fast in Python. So a few lines of code and a lot of modules that you could easily use, and you can do very large projects with it for your thesis or any kind of research that you want to get done fast. It has a readable and very clear syntax. So I'm going to talk about it on the code when I show that to you. On average, the Python code is 3 times smaller than any other code. So you have to just write a few lines of code and you're done. It doesn't need declaration of arguments or variables. So people who have prior experiences with programming languages like C, C++, Java, it is not like those that you need to know what kind of variable you're going to initiate. You can change it on the fly and it will automatically decide what is best for you. And you can do dynamic declaration, and you could just throw away variables. It does garbage collection for you automatically, so way easier than C. And it is interpreted and not compiled, which means you don't have a compiler. You have something called an interpreter that reads your code line by line and executes them. So that is good in some ways and bad in other ways. It is bad because it's going to make Python one of the slowest programming languages. So if you are not careful with your programming, you could easily write a program that is like 20-30 times slower than C. But if you are careful, you can get similar performance, but write much less code. So in the interpreter board, you don't need any pre-processing of the code. You can just open up an interpreter and start writing a = 1. So I'm typing in code line by line and it is executed at that time. And what is Anaconda? Anaconda is a package is a virtual environment manager for Python. And what do I mean by that? Imagine you're working on 3 separate projects and they all need the same library, but they need the different version of that library. So what are you going to do? Are you going to install all of them? What happens then? How do you differentiate between them? Conda is a place where you can create virtual environments, and we mean that in those virtual environments you can have different versions of Python with different packages installed, and they are completely isolated from each other. So if you need Python 2.7 for one project and Python 3.6 for another project, it's completely cool. You can just go to that virtual environment and run Python, and it will automatically be that version that you want. So it does a lot of things. It also is a package manager, which means you can install other libraries, code that other people have written, and you could install them easily without worrying about what it requires, how it's going to compile, and how you can make it and stuff like that. So assuming that you have it installed and regarding how you can access it, there are different options when installing it. If you have chosen for it to be available in the command prompt, you can just type in Conda here and it will output some help like this one. But if you haven't chose that option, you're going to need to go to something like Conda command prompt or something like that. On a Conda prompt, yeah. So whichever you have chosen, just open it up and write Conda-V. This should give you the version of your installation of Conda. So we want to create a new virtual environment so that we can install anything we want, and we can run the code that I'm going to present here today. So you're going to have to type something like this: Conda create -n, and then you specify the name. The name could be like Python Workshop, PWS. And then you could say something like Python equals 3.6. So this will create a new virtual environment for you with Python version 3.6 installed inside it. It will also install some other stuff like Peeppeep, which I'm going to talk about just now, and it will install something like Visual Studio Runtime, which makes life pretty much easier for you if you want to install a lot of packages. So we are done with the with creating the virtual environment. So what I'm going to do now is type in Conda activate PWS. This means activate this virtual environment for me. And when it's run successfully, you will see something like this just before the path.
What's the advantage of having each one?
As I said, for example, imagine you have 2 projects, and in one of them you have to use Python 3.6. In another one you have to use Python 2.7. When I'm inside this virtual environment, I can just write Python, and the version is 3.6. But if I open a new command prompt and just write Python, it is 3.7. So I have Python 3.7 installed on my laptop, but inside that virtual environment, it assumes that I have Python 3.6. So here we have our virtual environment set up, and we are ready to go with the rest of the stuff. The next one is Peep. Peep stands for Peep installs packages or Peep installs Python. Doesn't matter. So it's basically a package manager. Imagine someone else has written a code and you want to use that code. You want to use that library. Each programming languages has their own way of dealing with this. For example, in C you will have to use shared libraries. in Java, you will have to add it to, I guess, Maven or any other package manager you have in Java. In Python, that is mostly pip. So you could just write pip install and the name of the package that you want, and it will install it for you. So if I just here pip install numpy, it means I want to use a library called numpy. Go ahead, find it and install it for me. And it will automatically download it, install it, and set it up for me. These are some of the modules that we are going to use today. So one way to install them is write pip install and the name of each of them one by one. We could also do something else. If you go to the repository, we have a file called readme.txt. Let me change the font here. Okay, so in this requirements.txt file, I just wrote the name of the packages that I'm going to need, and I can install them all at once. The way that goes is you just copy this path and change your directory into it. So cd that path. Now we see that we are in this path. Now I write pip install -r means install the requirements, and then the name of the file, requirements.txt. It will automatically install everything I have listed in there. You could also specify specific versions of these libraries. So I could just write Jupyter == some specific version. And this is a nice way to list the requirements of your code. So whenever you want to use them later on, or you want to install it on another computer, it would be easy to do. Something else that is in the environment of Python and could come in handy is Jupyter Notebook. Jupyter Notebook is basically something like an IDE, integrated development environment for you. So what happens is you go to the directory that you want to work on and then write Jupyter Notebook. This is the command, and it launches something like this in your browser. So I have 3 notebooks here. One of them is Introduction to Python, another one Introduction to ML, and this online code will be anything extra I'm going to code today. So in here I could write a lot of text. I could use HTML, CSS to format it. It also accepts Markdown, if you've ever done Markdown anywhere before. So you see that it looks pretty nice, and I can write blocks of code that can be run all together. So for example, if I write a = 1 here, and I press Ctrl Enter, it's going to execute that for me. And now if I do something called print, it will write the value of a for me. So Jupyter Notebook is available in a lot of languages. You could do R programming in there. It has some nice features that I'm going to show you later on, especially if you're working on a machine learning project. It will be very easy to do in Jupyter Notebook. So let's go to the basics of Python, Jupyter Notebook. Take a look at what we will be doing today. Is the font good? Can everyone see this? Okay, so I'm going to just go one step further. So As I said, I can have different blocks here. So this is a Markdown block. As you see here, it's noted. And if I execute this, it will render it for me. So the way you will print something in Python is writing print and then give it a string or any other variable. It will be printed for you. And in Python, the strings can either be shown with double quotation or single quotation. It doesn't matter. Both of these show that the text here is a string and not a variable name or anything else. So if I go ahead and press Control Enter here, it's going to run this for me. And I have no idea why it's taking so long. Okay, so let me restart my Jupyter Notebook. Okay. The problem was that I put my computer to sleep after running the Jupyter Notebook, so don't do that. Restarting Jupyter Notebook just fixes it. So any of these that I run, it will write the string that is placed here. We have literal constants in Python. So if you have done C, if you want this constant to be float, you have to write something like this. But in Python, if you write just 5, this would automatically be an integer. If you write, for example, 1.23, this will be a float. So these are literal constants. As I said, the strings can either start and end with single quotations or double quotations. We could also have multi-line strings, which is shown with 3 single quotations or 3 double quotations, and you will mark the end like this as well. So as you see here, it's automatically inserted the \n, which is something that would be shown nicely if you print it. So for formatting and printing other stuff, for example, a string, integers, floating points, anything else, you could just use the format function. So the way it works is you create a string, just like this one. So let me open up a new one here. I could just create a string, hello everyone, and then dot format, because this string is object. So everything is Python is an object. If you've done object-oriented programming, everything is an object here. So integers are objects, strings are objects, booleans are objects, everything is objects, even functions, which we will get to later on. So you could just right here put something like this empty brackets and have format 0. So wherever I put an empty bracket, it means that this would be a value that I will pass to you later on. And then when you run format and you pass that value, it will be automatically inserted in the order that you put it there. So if I write something like this and then format 0 and 1, the first one will be the first argument that we pass to format, and the second one will automatically be the second argument that we pass to format. So what if I want to change this order? I don't want to change what I pass to format function. I could specify that I want this to be the first thing that I pass to format function, and I want this one to be the second one. And we can change the order in that way. It works with all kinds of variables, so you could just write something that is a double or float or a string, and it will automatically convert it to a nice format for you there. But what if I want to format this floating point here and make it only have 2 decimal integer and decimal points? I could write :.2f. This means I want only 2 digits after dot. So we could limit the number of decimal points that will be shown there. We could also specify that I want the length to be 8. And if we don't have that many numbers, it will insert blank spaces there. So this will be nice for printing a lot of things, and you want all of them to be aligned and look similar. For example, if I want to print this and then print 1 over, for example, print 2 here, you can see that they look like they have some sort of indentation that makes them look very bit good. So we have seen formatting, we have seen printing, and if you take a look at here, you see that every time I call the print function, it automatically inserts a new line character here. So sometimes we might not want that, so you could specify what you want to insert in the end of that string that you're passing to print function. So I wrote here that I want you to insert a space after writing this. So you see here we have a dot and then a blank space. And in Python 3.6 and later, we have something called fstrings. Fstring is an easier way to do formatting without calling the format function. So this is a formatted string. The way you define it is you just write an f just before you start your string. Here inside the brackets, you can write any Python code you want. You could call a function, you could write the name of a variable, and it will automatically write that for you, print it anywhere you want. So as I said, you don't have to define the type of variables that you are using. So here, if I write I equals 5, and I print the type of I, it is of class integer. But if I write 5.3, it is of class float. 1 over 3, again float. And you could just put any variable you want here, and it will automatically find out what type of variable it should be. So indentation is very important in Python. So if you have done programming in languages like C or Java, you see that you do not need to do indentation, but if you do it, your code looks pretty nice, and people encourage you to do it all the time. So the way they went about it in Python is that they said if everybody is doing indentation, why not use it? So in Python, indentation is very important, and if you don't have the correct indentation, your code will not run. For example, here I wrote I equals 5, and in the next line I added a tab there. So I just did tab here. And because the indentation is not right here, it is going to say unexpected indent. So you have to follow the indentations in Python code. Let's get to operators and expressions. Plus means addition. This is how we specify multiplication. This means 2 to the power of 3. This is 11 divided by 2. This here, double slashes, means 11 divided by 2, but get the floor of the result. So it will round it up to the nearest smaller integer for you. Modulo is percent. So 11 modulo mod 3 is 2. We have left shift right like this. So if you've done binary, you know what left shift is. You just shift the bits one place and then place 0 in the places in the new places. If you have not done it, don't worry, you probably are not going to use it. So this is bitwise AND. Again, one of the bitwise operators. This is bitwise OR, this is bitwise XOR, and most of the time, most people don't use these, so don't worry about them if you don't know what bitwise AND is. And bitwise invert. So this is the less than operator in Python. Just like most programming languages, this is greater than operator. Less than or equal, greater than or equal, and this is how you check equality. So double equal signs is checking for equality, single equal sign is assigning a value to a variable. And not equality is checked like this. And you could use these kind of stuff for doing if else or something, while statements, stuff like that. You just do one boolean is another boolean. This means if this is true, do this. If this is not true, it's just like writing in English. So if I just have a equal to true, and for true false you have to have capital T here. I could just, if a is true, print yay. If a is not true, print nay. And you see that it's very easy to write conditions in Python. And this is how you do AND with booleans, or with booleans, you just write AND and OR. We have this sign, a plus equal 1, which means basically a equals a plus 1. This is shorthand for that. You could also pass several variables to the print function and it will print them beside each other. So I wrote here a is, and then I passed another object called a. It will write its value here after writing a is. So we get to control flow, and the if statement is written like this one. So if and a condition, then colon. Afterwards you go to the next line and then add an indentation here. So if I want to write it again, I say if a is true. This is my condition. So this will resolve to a boolean. And then colon, enter, and a tab. So you have to go one indent after that. And then I could write any code here I want. Afterwards, if I want to write some code that is executed outside of this if, I just have to do backward indent. So indent and then shift tab will take you back one step. So this is if. We could also have else if, which is written like elif in Python. This means if this condition here is not true, and then go to this part, if this condition is true, execute this. And then after a block of several if elifs, you could have an else, which means if all the conditions were false, were not true, execute this part of code. So here I could just get an input. So to get the input, you could just write input and a message here, just like shown there, and it will ask for an input from the user. So I could just write 3, and it says no, it's a little higher than that. I could just run it again. I want to guess the number 23. So if I write 25, it's a little lower than that. And let's get it right this time. Congratulations. So we have while statements. In while statements, as long as this condition is true, you will loop through the code inside this block. So here I don't have to execute this several times. I just write 2 is higher than that, 25 is lower than that, and let's guess it right this time, 23, and then the loop is done. We could also have an else statement. This means after you are done running this, run this, and even if running was false from the beginning, it will still work. Okay. Let's go to the next section, the for loop. First of all, I'm going to talk about list and range. This is online code. So we have arrays in most programming languages. Here we call them list. So if I write a equals 1, 2, 3 like this, and then print the type of a, it will be of the class list. So lists are pretty good in Python. You could just append to them. A.append, for example, 13, and then let's print a. As you see, 13 has been added to the last place of this list. If I want to delete one of them, I just write del, for example, a of 0, and then print a again. I just deleted the first element in this list. And in Python, the arrays are 0 indexed, which means a of 0 is the first element in a of 1 is the second, and then you go to the end. If I want to get the last element of this list, I just have to write -1 here. So this will be similar to saying end in MATLAB. It will automatically go from the start is 0. If you go one step backward, it will be the end of the list. And again, a-2 is the second one from the end of the array. We have something else called range. So if I write range 5, it will be an object which starts from 0 and goes all the way up to 5, but it is not inclusive. So let me print that in a better way. I will cast this to a list. Yeah, so it will be 0, 1, 2, 3, and 4. It is not inclusive in the end of the range, so 5 will not be there. If I write 1 and 5, it will start from 1 and go all the way up to 5. So it will be 1, 2, 3, 4. I could also specify the step size there. So I could say that start from 1, go all the way up to 5, and do it in increments of 2. So it will be 1, and then skips one block in the array, and then writes the next one. I could also have negative increments here, so I could say go from 1 to 5 to 1 in negative increments, which means go backwards. So if you want to do a for loop in Python, it will be like this: for some variable in a list or a range, anything that is iteratable. If you have worked with Java, they use the word iteratable. So I could say for I in range of 5, print I. So I is equal to 0 in the first iteration and it goes all the way up to 5, but not inclusive again. And it will be printed out here for me. Does anybody have any questions so far? Okay. We could also have an else statement in the for loop, which means after you're done, run this as else block of code. We have break and continue. If you have done programming in other languages, you're familiar with those. If we have a break, it basically means go out of the most inner loop. So if we are in a while here and we have a break here, it will go out of the loop. So let me write another one here. While let's say running let's have a for here. For I in range 10, print I. So it should work in 0 up all the way up to 9. So I could say if I equals 5, break. This means if this condition is true, break out of this loop. So it will stop running the loop and go out of it. Yep.
Question about for. It always excludes the last number, right?
Yeah.
Is there any way to improve that?
Yeah, you could write 6 here.
Yeah, that's.
Yeah. So to make it inclusive, you'll have to go one step further than what you want to go. But this is, I think, mostly due to the fact that if I write range 5 here, it will run for 5 times. Because it starts from 0, it will go all the way up to 4. So I guess that's why they chose this way. So as I said here, if we break, we will break out of this loop and we will not continue running the next iterations. We could also have something called continue. Continue. This basically means do not run the rest of this loop, this iteration but keep on running it, go to the next one. And what does that mean? It means it will run it for 0, 1, 2, 3, 4, and when it's running for 5, it will see, okay, there's a continue here, so I should not run the rest of this loop, go to the next iteration. So we don't see a 5 here, but we still see 6 and beyond. So let me copy that, have the break one as well. So break breaks out of it, continue continues running that loop, but skips this one. So for defining functions, yep.
You don't write any end for.
No, as I said,
another for.
What we do in Python is, as I said, indents are very important. So a block of code is identified by its indent. So if I want to have another for inside here, let me have that. So I want to have an I go all the way up to 3 and then have another for inside. For j in range 3 again. Print I and j. This means this block that has one indents in the beginning will be the outer for loop. The block that has 2 indents in the beginning will be the inner for loop. So it's like when you're doing it in C, you will have something like this here and this here.
Yeah.
But since it already has an indent, they said let's get rid of these. Yeah, at first it's a bit confusing, but it will result in very readable code. So if you're looking at code that other people wrote, most of the time it's very clean because they have to do indentation. So for defining functions, you write def, which means I'm going to define a function, and then the name of the function. So let's say func name. Then inside parentheses, you will write the arguments you want to be passed to the function. So let's say a. Afterwards, you will have a colon and enter. On the next line, you have to have an indent to specify a block of code that is going to run inside that function. So I do one indent here, and then, for example, print what has been passed to this function. So if I run this, I can see that func underline name is an object, but it's of type function. So if I say func name, for example, 12, it will print it out for me. Let's have something else here. The value passed is, and then, yeah. So since functions are objects, you could easily pass them into other functions. So you could have an argument that is a function, or you could do anything you want with them. So here I just wrote hello world inside this function. This has no arguments passed to it, and we can call it just like we would expect, the way that we're going to call it. We could do if else statements here and pass multiple stuff there. So let's talk about local variables. So all the variables you specify in Python are usually global. So if I'm not inside the function or inside the loop or inside anything, what I'm writing are global variables, which means anybody inside this program has access to it. So if I write x is equal to 50, and I define a function print x here, print x, I just call print x and it says 50. So I did not pass this variable to this function, but still, because it's a global variable, it has access to it. So what if we changed the function, so print x2. I want to change the value of x and then print it. Print x2. As you can see, it writes the value 2 here, but if I print x here, it is still 50. So the way that is going on is, since I assigned the value 2 here, this is now a local variable. So since it's a local variable, it is not observed outside of this function. I cannot access this variable outside the scope of this function. So when I run this, it will have a local variable called x, but it will not change the global one. So again, if I write print x here, I will see the global value that is not changed. It's still 50. Let's do print x3. Here I will have I could write something called global. So here I say global x. This means that x is a global variable. So if I change it after doing this, I'm changing the global variable of x. So if I run this code, I still this should be changed. I see 3, and if I print x now, it has changed. So that function now changed the global variable x, not a local one. So this shows that again, x is 50, and then here x is 50, then we change it. The local x becomes 2, but the global x is still 50. Just like we talked about now. So as I said, global statement makes it global. So if you change it, the global variable is changed. Now let's see how default variables work. I could have default values for the arguments that I pass to my function. So I could write a equals 1 and then print a. So if I run fun1, I did not pass anything to it, so it will use the default value of 1 that I specified like this. I could also have some arguments that are required. So if I do not specify a default value for it, it is required. So if I run this, I'll get an error. We are missing one required positional argument called b. So let's print a and b here. So if I pass the value 2 here, b is equal to 2. This is the first argument that is passed. The second one, since it is not passed, it uses the default value there. So we could also have named variables. I will show that to you. So let's make this form too. So now I just, okay, so it's writing 1, 2, 3 here. I passed only one value, which is 2. It will be assigned to B. And then A and C will get the default values. But what if I wanted to specify C but have A use the default value? Because if I do 2 and, for example, 4, this will automatically be the value of A. I cannot change C without changing the default value for A. So if I wanted to do that, I could specify it like this. I could say, I'm passing you another argument, but I want this to be equal and to be written inside the variable C. So this time, the third one is 4, which means that it has changed the C, but A is still the default value. So in using like most of machine learning area libraries, you're going to have to pass like 100 arguments into a function. You could just specify 2, 3 of them and then have the rest go with the default value. So this is basically what I just told you. We could have a variable number of arguments passed to us. So this basically means that we could have hundreds or thousands of arguments passed to a function, and it can handle that. So the way it goes is that you could have, if I do this, B will be required, A will not be required, but it's a positional value. So if I write something after B, it will automatically be A. And then if I do more than 2 arguments here, if I go with like 10, 20 arguments, the rest of them will be inside numbers. And this that I have specified with double star means the named arguments. So as I wrote there, C equals 4, that is a named argument. It means it is not based on its position, it's based on its name that is going to be assigned. So those go inside this variable, but we could skip that here. But read more about this in the book that I have mentioned, in the URLs specified on the repository. We have a return statement, which is just like what you would expect. If you want to return something out of a function, you just return it. We have something called docstrings. Docstring is a multi-line string just right after the definition of one function. And what it does, it automatically creates this as a README file for your function. So if I want to show you, we could show one nice feature in Jupyter Notebook. I have a function here called printMax. I could write print, do tab, it will automatically suggest the printMax here. But I'm not sure how I should use this function. So I hold shift and do tab. This means shift tab is give me the help for that function. So as you see here, it shows the signature. So it has 2 arguments passed to it, X and Y, and it has a docstring, prints the maximum of 2 numbers. So it will be shown pretty nicely here, and most IDEs work very well with docstrings as well. So just cut that out. This gets us to modules. Modules are a block of code that you or someone else has written and has everything you need to use it inside it. What I mean by that is, imagine you wrote a piece of code that uses OpenCV library. If you just have that as a module, you have the requirements.txt inside it that says, I need OpenCV to run this module. It will automatically install your module, install OpenCV, and any other stuff that your module needs. So I wrote a module here, but I'm not going to go through it because we don't have much time and I want to get to the next section. We have a function called dir, which writes all the possible functions and properties inside an object. And the way you import modules is you write import and then the name of the module. You could also just import one variable or one function from that module, which goes like this: from math import sqrt. So I just want to use the square root function from the math library, so I can import it like this: from the name of the library, import the name of the function or object or anything else that you want to import. And you could just import everything like this: from Fibo import star. So if I don't write it like this, if I say import Fibo, if I want to use a function inside that library, I will have to say Fibo dot the name of that function. So for example, Fibo dot Fib of 2. But if I say from Fibo import star, I do not have to specify the name of the module here. So I can just Fib of 2, write it like this. I could also do something else like import Fibo, but I want to call it something easier. I can say as FB. So it will again import Fibo module, but I can use it with the shorthand FB. So I can say FB dot Fib and 2. So this is the way you use modules. We also have different data structures. As I said, we have lists. We have a function called len, which gives us the length of that list. We can loop through it like this: for item in the list. Append, sort are stuff that you would expect them to be. You can append something at the end of that list, you can sort it. You could get an item out of it or delete an item. This is something called a tuple. Tuple is like an object, but it can only have variables inside. So you can pack like 3 or 4 variables inside the tuple. It cannot be changed after creating the tuple, and it is mostly used for returning several objects all at once from a function. So if I want to have a function takes nothing, returns 1, 2, 3. So this is a tuple, and I could just say a, b, c is equal to font3, and then if I print them, font3 doesn't take anything. Yeah. So as you see, I have put some value inside several variables all at once from inside the function. So this is mostly the way that they use tuples. We have something called dictionary, which is something like a hash table if you're familiar with it. So it has a key and a value, but the most important property is that you can access these variables randomly very fast. So if you want to look through something, it is much faster than a list. This is called dictionary. So this is slicing. Okay. I'm going to talk about slicing. If I say A is equal 1, 2, 3, 4, 5, 6. So this is a list. If I want to get a subsection of this list, so if I want to start from this number 2 and go all the way to 5, I could just say A of 1, 2, the fifth argument, not inclusive. So this is 0, 1, 2, 3, 4, 5. It's not inclusive, so it will not have this value. So it grabs this section of that list and returns it. If I say A colon, this means start from the position 1, so it is 0 index, this is 0, this is 1. Start from here, go all the way to the end of the list, the array or list. I could also have it like start from beginning, like this. If I don't write anything on that side of the colon, it will mean start from beginning, go all the way to 3. It's not inclusive, so it will only grab 0, 1, and 2 here. I could also specify a step. So this means go in increments of 2. We could also have negative steps. So having this mean start from anywhere you can. Go to anywhere you can, but go in increments of -1, which means go backwards. So it will start from the end, go to the beginning, and go backwards. Yeah.
How do you define a second row for that?
A second row, that would be a list of lists. So it's not like MATLAB in that sense by default. So the default list type in Python is one-dimensional. But since you could have any kind of variable in there, you could have a list that each of the elements is another list. So maybe I could do, it's a list, so the first element in that list is another list. 1, 2, 3, and 4, 5, 6. This will be something like this. But if you want to do matrix manipulation, to be easy, you would have to import a module called NumPy. So I could just have np dot, for example, zeros 3×4, and this is a 2-dimensional matrix, and you could do matrix manipulation with it and anything else you want. So it is basically something like MATLAB, and it has all the functionality that you would need with matrices. If I want to check if a number is in a list, I could say check if, for example, 4 in A. So since we have the number 4 inside the variable A, it is true. If I said, for example, 9, it would be false. So if you want to use it in an if statement, it would be if 9 in A, print 9. Since this is not true, it will not get executed. You could say also if 5 in A, print 5. And you see that 5 is actually in A. So we could have something called starts with, which is true if the string starts with this one. We could also check if the substring is in another string. So it's like search if there is an A inside this string, say yes, it contains A. Okay, since we don't have much time, I'm going to skip the object-oriented programming part, but it's very easy to learn, and I have listed a source here, A Byte of Python. It is a great book, and if you want to go further with Python, you could go with it. Let's have a 2 minutes of recess, and then we can get back to the machine learning section, the second part of the workshop. If you want to have more information and read more about this stuff, these are some useful links. And again, here, this is the link to that, A Byte of Python. It's an online book that you could just read for free. So, see you in 2 minutes.
For the refreshments, you guys can have it.